Well, I hope this is not going to be a noisy video because we have some construction outside of my windows here in my office, but I'll do my best to be clear. Anyway, this is another linear programming problem where we're going to be using what we call the minimization of the cost, minimizing the cost. And it's a word problem which is going to help us also trying to show you how to figure out the way to do the layout for the model. So again, I got this one here from this fantastic website. It's called exceltactics.com to give credits when credits is due. And here's the problem. In this scenario, medicine is sold in 3 different sizes: 50 milligram, 150 milligram, and 450 milligram. This is actually those here, in, as you notice with my cursor. And the bigger sizes come at discount price to the smaller one. Obviously, yeah, we can see that. When you have 450 milligram, you pay only $26 something versus 150 for $11. So the challenge is to build a spreadsheet that will calculate the lowest cost combination of medicine vials based on what a patient needs. All right, let's take a look at the other giving data that is really basically not the best way that we should really lay it out. So we're going to figure out how to improve the layout. This is the vial. I put those here horizontally right away here. We have 50 for, we could say here vial 1. Vial 1, I hope I'm pronouncing this word correctly. I never used it before, so it's going to be here. Okay, I'm going to go ahead and steal the format from here, so I'll be able to actually make it more meaningful to you guys. And I laid the cost also as well horizontally here for each file. And what we're trying to figure out is really the quantity that each one of them these files is going to minimize the cost here, basically. This is the quantity that we're going to really force, and the model is going to really pick up for us as the optimal solution. This is the second amount, and this is the third quantity or number. So what we need to do is, there is another piece of data is giving to us, which is very critical, that the person should have at least the 3,841 milligram, because this is a medication we cannot give them less. So it's better to go ahead and get them more. So the constraints is going to be greater than or equal to 3,840. Anyway, how to do the total dosage of all this is to multiply again this by this, plus this by this, plus this by this. We'll learn this is going to be done very easily if I use some products. So some products is going to be this, comma. I could lock it if I need to repeat that, but I'm not going to lock it at this moment. Multiply by because only a couple problems, actually a couple calculation. B11, calling D11, comma B6 through D6, and we can hit here. The result, of course, at this moment is 0 going to be. And another way is to really go ahead and do the objective function, which is again the minimization of our cost. What is our cost? Our cost is going to be the multiplication of all this multiplied by the multiplication of, multiplied all this by the corresponding value for this range, which is again sum product is going to be the perfect function to use that. So sum products, and we're going to go ahead and, I could have locked this and copy it, but I'm not going to worry about it now. It's a very, very short problem. So here we go. So this is going to be also 0 initially. So this is going to be solved for us by the model. And this is the constraints. Only we have one constraint, that the total of the milligram must be less than, greater than or equal to 3,841. You need to really be careful about the direction of the operation, or the relational operators in this case. Greater than or equal versus less than or equal could really mess you up. What they found, actually, the solution, already they provided us the solution, so we could really check if we have done our work correctly or not. they found the total to be 3,900 and the cost is 237.60. 60. So we're going to actually make sure also that quantity for each file must be an integer. We cannot have a fraction or a piece of a milligram because we need to get it as actually a whole value. Let's go ahead and see, first of all, before we impose the integer restriction on the calculation, what are we going to come up with? Remember, we cannot have more than, we cannot have less than 3,841. And the objective function is going to be minimizing the cost. Okay, not maximizing the cost, we maximize the profit, we minimize the cost. Here we go. We're going to go ahead and do the data. We're going to go to the solver, and now I'm going to go ahead and look at the objective function. This is my objective function right here. What am I solving for? I'm solving for, the model is going to solve for this three numbers. Okay, and I'm going to go ahead and delete this. Obviously, I need to be able to put the constraints. My constraints I'm going to add. It's going to be this value, which I use the sum products function for it. It has to be greater than or equal to, so I change the direction of the logical operators, the relational operator toward the greater than or equal than this constant value, which is the 3,841. And remember here, we're going to go ahead and add, okay, and this one here is the objective function that I calculated, which is the cost. Make sure that this is minimization, or min is the one that's being selected. And I'm going to make sure that this is a simple linear programming, and I'm going to solve, and I'm going to drag it from the other screen to show you what we come up with. And if you notice here, it's going to give me actually utilizing everything 3,841. I would think this is the perfect solution beyond optimal. However, there is a problem. The problem is that 8.533, this is not an integer value, and that's not going to really work for us. We need to have an integer value. They don't sell like half of millimeters or fraction of a millimeter. They sell only a millimeter. So I need to impose that all these values must be integer, and I'm going to show you that in a second. You don't have to reinvent the wheel, of course. We could go and add to the constraints that this value, all these are three value. I'm going to go ahead and say it must be integer. So we cannot really allow it to be anything than integer. All these values, the yellow area is going to be integer. Okay, and now we're going to solve this problem. And obviously there is a solution. And if you take a look at it, it's going to give me what they suggested, obviously, the 3,900 total dosage. And the amount of the cost that is going to be 237.6, and go ahead and make it a dollar figure so these people will know that they have to pay this, and it is greater than 3,845, and that's basically they did already arrive to the optimal solution. But I wanted to show you how did we also come to the same exact answer, why we didn't reject that first one, because it wasn't a whole number, it wasn't an integer. I hope you learned something. So now we could really fully understand the minimization of the cost. And of course, in the previous video, you probably looked with me at how to maximize the profit. Thank you very much for your time, and I hope you have a great day.